Hey y'all, this is going to be the Unit 6 review video and the practice test guide. I'm actually going to start with some notes before going to the practice test, which I recommend that you copy this down, you use your note card, make your note card using this information. So we're going to start with confidence intervals. And big picture, like what are confidence intervals? Like what are we using for? What's the point? The whole point of confidence intervals in this unit anyway is to estimate the true proportion of something. So this true proportion, that's also known as the parameter. And we do that with a statistic. Okay, so what we do is, drawing the visual for you, is we get a statistic, we put that in the middle, and it's called the point estimate. And then we calculate what's called the margin of error. And we add and subtract that from our point estimate to get our interval. Okay, so let's do an example and then we'll move on to the practiced question. So let's say I want to know, this is what we did in class, but the percent of all Summit students going to prom. So let's just say in this example, like all Summit students can go to prom, like underclassmen. So this is the parameter. This is what I'm looking for. Okay, I want percent of all Summit students go to prom. So I take a sample, and this will be given to you in the question. I take a sample of, let's say, 30 students, and 10 of them are going. Okay. So my statistic in this case, my p hat, is 10 divided by 30. Okay. And 10 divided by 30 on the calculator will be 0.33. So we're already building our confidence interval, right? That's that middle point right here. Your statistic, this is statistic p hat. Okay. Now, I'm going to take a moment before we continue to go over the conditions. You have to know the conditions or have them written down in your notes. Okay. Conditions are random, independent, and normal. To check if it's random, that will be given to you here. It would say in the question it was a random sample. So I say pass because random sample. So you would check that off. So on the test, I need to see like a because statement. You can't just say yes, you have to say why. Independent is where the n has to be less than 10%. This is the 10% rule. What that means is, so remember how we had 30 students total? And that was out of, let's say, like 400 students. Well, 30 divided by 400 is 0.075, or that's also 7.5%. And since that 7.5%, right, this right here, since that is less than this over here, we're good. Okay, that's what you're checking. Remember, this is my sample size up here. That 30 is a sample size, and the 400 was like the total population. So what I did was I divided the sample by the population and got, it was 7.5% of that, and that's why. So I would get, this would be given to you. This would be given. That's 400 students in the entire class, 30 in my sample, 7.5%, less than 10%. So I'm good. We check that. And the last one is normal. And normal is, in the case of confidence intervals, NP has to be greater than or equal to 10, and N1 minus P has to be greater than or equal to 10. So my N and my P, well, my N is 30, and my P is 0.33. So 30 times 0.33 is, we'll round that up to 10. That's 10. Okay. And then on the other one, 30, 1 minus P is 0.66. 30 times 0.66 is 20. Yes, roughly 20. So it would check the normal. You're plugging in your sample size and your proportion. In the case of confidence intervals, it is a p-hat. I don't want to confuse you here because it's different for the test statistic, which we're going to do later. But for this one, we used this as our p-hat, and it's going to be 30. There's only two values. There's no regular p. It's different in the other question type. Okay, so we're good on conditions. Moving forward. Now I can build out my confidence interval a little bit. So remember that my statistic in the middle here, my p-hat, my point estimate was 0.33. Now I need my margin of error. The margin of error is made up of two numbers. It's a z-score multiplied by the standard deviation. Okay, this is margin of error. So let's start with the z-score. Where do you get that from? Well, it depends on my confidence level. So this is from the practice test. These are different confidence levels I can have. The more confident I am, the bigger the number. So let's just say for this example, we're going to do a 90% confidence interval. And that means in my notes, I'm going to have to use this one because it's 90%. So we 1.645 is going to be my z. And you're just going to take that from the table. So again, this right here from table. The standard deviation is the more difficult part. That the equation of standard deviation is sigma p hat is square root p1 minus p all over n. We've been doing this in class. Plug in your values. 0.33, 1 minus 0.33 all over 30 square rooted. I'm going to do this in the calculator. I'm going to show you my steps. I know you're using a different calculator, but it's still, I'm going to treat it like it's a regular scientific. Here's what I do. I start with the subtraction. You start here with the parentheses. 1 minus 0.33. Enter. I'm then going to take that value, that's 0.67, and multiply it by the 0.33 times 0.33. Okay? I'm going to take that's all that together, and divide it by the 30. And now I got to square root this. So the square root is the same on most of the calculators. It's going to be, most of them, it's like a blue button here. Second. And this button gets me access to that checkmark symbol. So you can see here I'm checkmarking. And then I can either type in that previous number, 0.00737. I can do that. Or I can use another shortcut, which is down here. See this ANS button here? You'll see this in most of your calculators. If you click second and then the negative sign, that'll put that ANS is just this previous number. So you don't have to worry about retyping it. And I get 0.086. I'm going to round that. This is 0.086. So now I've got my two values. 0.086. We're going to multiply them together. 0.086 times 1.645 is 0.141. So what that means is, back up here, this 0.33 in the middle, I'm going to have this distance from here to here, its margin of error, is 0.141. So I need to add it and subtract it from 0.33. So I'm going to calculate again. 0.33 plus 0.141, 0.471 right here. And then 0.33 minus 0.141 is 0.189. So my confidence interval is from 0.189 to 0.471. The way that it's written would be like this, like a parentheses, 0.189 comma 0.471. And then the last part is the conclusion. So the conclusion says, we are, whatever your confidence level was, 90% confident that the true proportion of students going to prom is between 0.189 and 0.471. Okay, so that would be your sentence structure. We are some percent confident that the proportion of students going to prom is between two numbers. Okay, so let's go to the practice test. Number 1. So if you watch that first part, what I actually want you to do is take a second and do this by yourself. Okay, so I want you to try without my help. Go through the entire thing, see if you can do the whole thing. Use the notes that you took before as a guide to help you. And I'm going to give the answer now. So go ahead, pause and try, and then click play. Okay. The New York Times conducted a nationwide poll of 1,048 randomly selected teenagers to estimate the proportion who have a TV in their room. They found a proportion of p hat is 692 over 1048 equals 0.66 with TVs. So some of the steps have already been done for you. So if we think about our notes before, how I did 10 over 30, I had to calculate that myself. This is actually already done for you. So we have our p hat. That's good to know. I'm going to go ahead and box that because that's an important value. And other important things to note here, this value right here is my sample size. So I'm going to mark that down. It's a good practice just to make sure you know what your p hat and your n are. And we're making a 90% confidence interval, which is very important. Okay, so what are we looking for? Well, we're looking for the true percent of teenagers with TV in room. Okay, that's what I'm looking for. My confidence level is given to me. That's 90%. And this is what's called a one prop confidence interval, right? It's a single proportion. So that means one prop, one proportion confidence interval. Is the randomness condition met? So again, thinking about the notes, random is going to be given to you. Let's see. Oh, look here. See what it says? Randomly selected. That's very important. So here, yes, the sample was random. Was the independence condition met? You note that it gives you this big number because this is the it's giving that big number because that's the total number of teenagers. That's your population size. So reminder, this is the 10% rule. You take your sample size, 1048, you divide it by the population size, 29,35,066, and that equals, on the calculator, 1048 divided by 29,35,066. It's a very small number. Okay, I'm getting like 0.00005, so it's very small. So this is less than 10%, so we're good. Normality conditions, again, that's NP, needs to be greater than or equal to 10, and N 1 minus P needs to be greater than or equal to 10. So my N, again, that's that 1048 times 0.66 is 692, just around that, which is fine. You can check that one off. And then N1 minus P will be 1048 times 0.34, which is 356. It's also fine, above 10, right? So you have to prove it to me that both are above 10. Good. Now that we've tried the conditions, now we can go to doing the work. And this is actually right. So over here to the right, this is where you want to look at your confidence level. So my confidence level is 90%. So you need to choose the right value based on your confidence interval. If it was 99%, you'd have to do this one. If it's 80%, you do this one. But it is 90%, so I'm going to stick with that one. Standard deviation is that formula, square root P 1 minus P over N, which would be, in this case, we'll sub in the values. It's going to be square root 0.66, 1 minus 0.66, all over 1048. Okay, now we're going to do it. Same thing in the calculator. As a review, in case you're not getting this right, 1 minus, I do the subtraction first, times it, divide it, square root it, second, x squared down here, answer, enter, 0.015, we'll round that up, 0.015. For the margin of error, I take that value, 0.015, and I'm going to multiply it by my z-score, 1.645. And that equals 1.645, 0.024. So now the interval part, this doesn't have the drawing, but I'm going to go kind of draw the drawing below so that you see what's going on. Again, in the middle is 0.66. And I've got to add and subtract this number. So we do 0.66. Plus, it's going to be about 0.684 over here. And then if I subtract, so again, minus 0.024, 0.636. So my confidence interval is from 0.636 to 0.684. So we say with 90% confidence that the true proportion of teens with TV in room is between 0.636 and 0.684. Okay, so this is a complete question. I'm happy with this answer. Let's look at E and F. So if they had instead sampled 2,000 teenagers rather, and let's assume like that proportion stayed the same. What's going to change here? Well, what's going to change is that standard deviation. You're going to be dividing by a by a bigger number. So it's actually going to get narrower because the standard deviation will decrease because you're dividing by a big number. Instead of dividing by 1048, you're going to divide by 2000. It's going to decrease. And then if it was 99% confidence instead of the 90%, what's going to happen? Well, look, the more confident you are, the wider it has to be. So if you have 99% confidence, it's going to be wider because it's a higher z value. Okay, that is confidence intervals. Let's move on to test statistics. Hypothesis testing. So I think these are a tiny bit more. These are a bit more complicated. So this is hypothesis testing. The way these work is you're given a problem and somebody's making a claim. So if you remember the example we did with Mr. Smith, where he said, "I have an 80%." I'm just gonna do that one. He said he had an 80% free throw average, and then we tested that, and we looked at whether that was true or not. So I'm going to use that same example again. So we start with the null. This is this H naught. This is called the null, and this is essentially repeating the claim. So if somebody claims something is true, Mr. Smith claims he's 80%. So you say P equals 0.8. It's always in that null. It's always going to be that equal sign. Always. So that's a hint for you. So it should never be anything different. And then you have to have an alternative. So the alternative is like basically saying, no, that's not true. So we said, that's not true. I don't think you have that high an average. I'm going to say it's less than that. Okay. And sometimes it can be greater than. But in this case, it's going to be less than because it makes sense in the context, right? And now we have the same conditions. So I'm not really going to repeat myself too much. Conditions are the same. Random, right, which would be given. Independent, which is that 10% condition. The one that's a little bit different is the normal. This one's a bit different. It's still the same formula, NP greater than or equal to 10 and N1 minus P greater than or equal to 10. But it's different. The p-value is slightly different. So in this case, I'll label things for you. So my p equals 0.8. The statistic depends. The p hat and the is given to you in a different context. So it'll be given to you in the question, but for this example, like Mr. Smith went outside and he shot 50 shots, so the end would be 50. And let's say he made, 75% of them, 70% of them, say 70, 0.7. Okay. So you should have, for the hypothesis testing, you should have 3 values, not 2. You should have 3, which is a difference because you have the proportion, the real proportion that they're claiming, and then you have their statistic. So when you come to this part in the confidence intervals, you use p hat. But since we have the p, you use this p, not p hat. Okay, so this one's going to be 50 times 0.8, which is 40, which is good. And then 50 times 0.2, which is 10. And then that 0.2 is 1 minus 0.8. That's why I got that. So we're good on normal. And the conditions are the same. And now, and the rest is very similar too. You have to find the standard deviation. So the same thing. We need to find standard deviation. And that's equal to P, again, 1 minus P, same equation, all over N. And you use, again, you don't use the P hat here. You use the P. You use the P. Okay. So this is the square root of 0.8, 1 minus 0.8, all over 50. Let's do it. So again, still, if you're feeling lost, 1 minus 0.8 times 0.8 divided by 50. Square root it. 0.057. Round that up to 7. So you need your standard deviation. And then I think what's the next most helpful thing is to draw out your kind of curve and like where things are. So we have in the middle, this is the P, 0.8, that's the P. And then somewhere on here we have this P hat, which is 0.7. And you now we need to find how many standard deviations this is away from the mean. So this is the z-score formula. So we're going to do the value 0.7 minus the mean 0.8 divided by 0.057. So it's value, right kind of below, value minus mean over standard deviation. It's always that same formula. So here we're going to have 0.7 minus 0.8, 0.7 minus 0.8 divided by 0.057 is 1.75, negative 1.75. Okay, so this over here is negative 1.75. Standard deviations as a z-score. Now we need to find the p-value here. This is the p-value. P-value. To find the p-value, this is where you're going to look at your z-table. I actually don't have a z-table on me right now, but I have it on my calculator, so I will tell you what it is. Negative 1.75. Okay, I'm getting a roughly 0.04. That's what I'm getting. So my p-value for this, so again, look in table, and you should get 0.04. Well, that's what I got. Then your last step is you compare this to the significance level. So the significance level, again, that would be given to you at the top. We would say like significance level equals 0.05. And if that p-value is less than the significance level, you reject. So in this case, I'm going to take over here. We say since 0.04 is less than 0.05, we reject the null hypothesis. We have evidence that Smith does not have an 80% average. Okay. So I'm going to repeat the same format as the last question, where I want you to do this. Some of you have already done it a little bit from last class, But if you haven't done it, maybe do it from scratch. Take a blank test and do it from scratch. And like look along with the notes that I just kind of gave you, and then come back to the video and watch me do it. Anyway, I hope you've watched it. Here we go. So, according to ESPN, basketball player Steph Curry has successfully made 90.9% of the free throws he's taken in his career. His teammate Klay Thompson thinks they aren't giving him enough credit, so he takes a random sample of 150 of Steph's free throws attempts, and he finds that Steph made a proportion of p hat equals 0.93. So, before we even go on, I need to define what my p hat, etc. is. My p hat is 0.93 given to me, right? That's the statistics. That's what Klay found. My sample size is n equals 150, also given to me there, which means the last thing I'm missing is that claim proportion, which is 0.909. That's this right here. Okay, 0.909. So what are we looking at? The true proportion of Steph's free throws. Right, I'm using shorthand. Significance level is given to us null. The null is, remember, it should always be P equals the original claim. The original claim comes from ESPN, right? Klay is trying to disprove that. So the original claim comes from ESPN that P equals 0.909. What is Klay saying? Klay saying, no, that's not true. That's not giving him enough credit. So that means it should be more. He thinks it should be more than that. Okay. So this is called a one prop Z test. Is there this condition met? Yes, because up here it says random sample. It was a random sample. Is the independence condition met? So this is the same as the prior question where so it's 150 divided by the total free throws that he's ever taken. 3766 equals 150 divided by 3766. I got 0.03, 0.04 basically, 0.044%, which is less than 10%. So we're good. Okay. Is the normality condition met? Again, that's NB needs to be greater than or equal to 10, and N1 minus B needs to be greater than or equal to 10. Let's test it. So it's going to be, remember to use the real P for this one. Use the real one, not the statistic, the real P. So it's going to be, the first one, 150 times 0.909 is 136. We're good on that front. And then 1 minus 0.909 times 1 minus 0.909 times 150. Yep, that also comes out fine. So it's 150 times 1 minus 0.90909 equals, I got 13.7, which is good too. So these are all good. So yes. Standard deviation, same formula, guys, same formula. P, 1 minus B over N. Write it down using the real P. So that's going to be the same as square root 0.909, 1 minus 0.909 all over 150. So in the calculator. Again, in case you're not sure, it's going to be 1 minus 0.909 times 0.909 divide by 150 and square root it. Enter. 0.023. Guys, my advice with the calculator is please do not do it all at once. Do one thing at a time. Okay? 0.023. Fine. Now, I think on the test, there will be sort of a place for you to sort of draw things out, because I think it's really helpful. I'll do a little sketch over here to the left so we can see what's going on. We have in the middle 0.909, and then we have our like statistic, which is 0.93. We need to see how many standard deviations that is away. So the formula again is going to be 0.93 minus 0.909 all over the standard deviation, which is 0.023. When I do this, you got to subtract the top and then divide. 0.93 minus 0.909 divided by 0.023. 0.91. All right. P-value. Again, you get it from the table. However, this one's a little bit different because on the table it always gives you the left side, and I want this side, right? So what you got to do is the value. I'll tell you what the value is you'll get on the sheet. You should get around. This is what I'm getting, around 0.8185. Like that's what you're getting, but that's not the area I want. That's actually the area. Like that's all this area here. If it's right sided, you have to take 1 minus that area. So you do 1 minus that. That's really your p-value, right? So that 0.81 is all this. The 0.18 is this side on the right. So it puts 0.18. So it's 1 minus 0.818 is 0.181. Okay. So then I take that 0.181, and it is greater than my significance level is 0.05. So that's not good. That means I cannot reject the null, and I do not have enough evidence. So for the last question, type 1 error is when it's a false positive, meaning that you say you reject the null but you shouldn't have. It's like when you're told you have COVID but you don't. Think of that. That's a false positive. You're told you have COVID but you don't. So it's when I do reject but I shouldn't have. Right? I was wrong. I rejected but I was wrong. That's a false positive. Type 2 is a false negative. That's when you're told you don't have COVID but you do. So it's when you don't reject but you should have. So this would be a type 2. All right, that is the practice test and the notes. Good luck studying.